Hi class, today we have the 8th lesson for matrix, and today's class is a very interesting one and it's very much important because multiplication of matrices is somehow hectic to so many students, especially beginners, and it's something that beginners usually forget so easily. You can understand it today, and if you don't practice, maybe tomorrow or the day after or the week after, you forget it again. So you have to be attentive for this class. All right, so this is actually the problem for us to solve, to multiply these two matrices. When two matrices are written without a sign given between them, it means multiplication. Okay, but this is the rule that we need to understand, a very important one. Now let us look at several cases here for you to understand something better. Now let's say we have here 2, 3, 4, 8. We have 4, 2 minus 1, 0. Yes, 2, 4, 3, 2, 1, 8. Then we have here 1, 4, 3, 6. Let's say here we have minus 1, 2, 6, 7. Then here we have 3, 2, 1, 4, 0, 2. Let us try to understand first which of these pairs can be multiplied. For addition and subtraction, two or more matrices can only be subtracted or can only be added if the orders are the same, if they are of the same order. For addition and subtraction, they have to be the same order. But here, it doesn't mean that they have to be in the same order. But multiplication has its own rule, which is somehow tricky a bit. Please pay attention. For addition and subtraction, if one matrix is 3 by 3, well, the other one again has to be 3 by 3, so that addition or subtraction is possible. If one matrix is 4 by 5, the other matrix has to be 4 by 5 for addition and subtraction to be possible. So addition and subtraction, the rule is so easy because the order has to be the same. Okay, mind you, if this is your first video for matrix, go to the first video. You'll understand what I mean by the order of a matrix. O-R-D-E-R, not O-T-H-E-R. So please, addition and subtraction, if one is 3 by 3, the other matrix has to be 3 by 3 for the addition to be possible, for the subtraction to be possible. If one is 4 by 4, the other has to be 4 by 4. If one is 2 by 4, the next one has to be 2 by 4. That one is understood. Now, what is the condition for multiplication of matrices? Well, let's say one matrix is m by n. The second one is n by m. They can only be multiplied if this and this are the same. I hope you can see it. One matrix is m by n, like this one, m by n, m by n. Let's say one matrix is m by n. The other matrix is n by p. The two matrices can only be multiplied if what comes after the by, don't call this times, don't call it multiplication. The symbol might be like a multiplication sign, but in matrix we say by. If what comes after by is the same as what comes before the by. So remember when I define order for you, or how order is defined in matrix, the number of rows by the number of columns. Let us try something here. For this matrix, how many rows do we have? 1, 2. There are 2 rows. How many columns? 1, 2. There are 2 columns. For this matrix, you always start with the number of rows before number of columns. Rows run horizontally this way. Columns run vertically this way. So how many rows here? 1, 2 rows. How many columns? 1, 2, 3 columns. So this is what we mean by M by N, N by P. So now my question is, can these two matrices be multiplied? Before I tell you, crack your brain and tell me if these two matrices can be multiplied. Yes, they can be multiplied. Why? Because this and this, they are the same. So this is columns, this is rows. So the condition goes like, if the number of columns in the first matrix is equal to the number of rows in the second matrix, those two matrices can be multiplied. If you have been copying, note that one and always be going through it. The number of columns in the first matrix has to be equal or has to be the same as the number of rows in the second matrix. The opposite is not working. So say, okay, what about the opposite statement? No, no, no. It has to be first matrix and second matrix. The number of rows, so number of columns in the first matrix has to be equal to number of rows in the first matrix. That is when we can multiply those matrices. Let's find out these two. How many rows? 1, 2 rows. How many columns? 1, 2, 3 columns. How many rows? 1, 2 rows. How many columns? 1, 2 columns. So this one here, are they the same? No, they are not the same. So meaning this and this, we cannot multiply them. And the one you don't need to struggle to understand is if they are of the same order. 2 by 2, 2 by 2. So if they are of the same order, of course, they will always be multiplied. 2 by 2, 2 by 2. 3 by 3, 3 by 3. 4 by 4, 4 by 4, and so on. But usually 4 by 4 is only like for universities. And most universities, we consider softwares. Yeah, if we have like lots of problems to solve, 5 by 5, 6 by 6, we use softwares to perform the multiplication because even this board will not be enough to handle like 5 by 5, 6 by 6. Okay, so I hope that one is understood. And when M by N, pay attention, please. When this and this are the same, the multiplication is possible, but your result is going to be this by this. Your result is going to be this by this. Look at it here. What this one is talking about. This and this, can they be multiplied? Yes. Why? Because the number of columns here is equal to the number of rows here. But our answer is going to be 2 by 2? No, our answer is going to be 2 by 3. Yes, the result is going to be a 2 by 3 matrix. Yes. Now, this one, is the multiplication possible? Yes, of course, this one is easy because this is a 2 by 2, this is a 2 by 2. And the result is also going to be 2 by 2. So, before we waste time, let's go. Okay. Now, let's see how we multiply this before we go to that one. Let's see the procedures because here it's somehow technical. Now pay attention, please. We say AC. Different teachers might have different ways how to perform, how to manipulate, or the procedures they teach their students to understand multiplication because we have different ways. But the good thing is, even 10 teachers or 10 different methods, the appearance of this stage is going to be the same. Probably the explanation is different, but the appearance is going to be the same. Just pay attention. Now we have AC. Can you see it here? Okay. Now this is what? BD. This is BD. The gap is a bit bigger, but you will see what is happening. Now we go this way. Do you see something like this? Something like n like. So we start here, we come to this, we go to this, go to this. So we start with what? E. E, E. Oh, I'm sorry. AC is this one. So we start with what? E. So we say E, E, plus, always plus. Write this one, B, D. We are done with E. What is next? G. So we say G, G. We have exhausted AC and BD. So what do? We leave a gap and start again. AC. Do you see the gap? All right. Now we are done with E here. G is done here. We go to F. So we say F, F. We say plus again. AC. We are done with AC, BD. So we say BD. E is here, G is here, F is here, and here is H. This is multiplication of matrix for 2 by 2. For what? 2 by 2. 3 by 3 is a different case. 5 by 5 is different from 4 by 4. Yes. 6 by 6 is different from 5 by 5. The higher the order, a different way is required. So now let's go to the problem itself. So we have here 2, 3 minus 1, 4, 1, 0, 2 minus 1. Please pay attention. So here is 2 minus 1. You see, from this to this, this to this. Just see something like n. Easy to recall. This one comes here. We say plus. We have used this also. Now let's come to this. 3, 4. Can we use one again? No, we have exhausted one here. We go to where 2. You can see how it is going. Yeah, we go to 2. This is 2. So we have used 2, 1 here, 3, 4 here. So we start again. So after the gap. So this is 2 minus 1. If you want to mistake with 2, realize that we've used here 1. This 2 is here. Time to use 0 now. 0 plus plus. So 2 minus 1 is this. 3, 4 is this. 2 minus 1 is this. 3, 4. So this is now minus 1. So before you continue, because one thing about matrices is that after you have gone far and you realize that you've made a mistake, going back and start all over again is boring and hectic. So before you continue, observe the pattern here. 2 minus 1, 3, 4. Memorize it like for just seconds. 2 minus 1, 3, 4. Be singing it. 2 minus 1, 3, 4. 2 minus 1, 3, 4. You see? Be singing it. Seconds. 2 minus 1, 3, 4. 2 minus 1, 3, 4. 2 minus 1, 3, 4. That one is good. Now this 1, 1, 1. This 2, 2, 2. This 0, 0, 0. Minus 1, minus 1, minus 1. It's so easy, but the process, you forget easily. Okay. 2 times 1 is 2. 3 times 2 is 6. Minus 1 times 1, minus 1. This is plus 8. After the gap, this is 0. Remember, 0 times any value. Plus times minus is minus. 3 times 1, 3. Minus 1 times 0, 0. Plus times minus, minus. 4 times 1 is 4. So this is 8. This is minus 3. Do not forget the gap. This is 7. This is minus 4. So this is multiplication of 2 by 2 matrices. I hope it is well understood. Thank you for watching. Don't forget to follow, like, share, and comment. See you in my next video.